Well, welcome back to the Azure Podcast. This is episode number 488, being recorded on the 27th of February, 2024, with special guest Jose Moreno. I'm Sujit, and on teams with me, we have Russell and, of course, our special guest, Jose, who we're going to get to in just a minute. But before that, we've got just a few updates to cover today. Russell, I noticed you had a couple that you want to talk about.
Yeah, thanks, Sujit. Yeah, just a couple for me. So the first one is a new feature in public preview for the Azure Application Gateway. So this is now introducing support for TLS and TCP protocols. In fact, it's the termination of those protocols that's put into public preview. So that lets you use Application Gateway now for non-HTTP type applications. So if they're using protocols like SQL, MQTT, AMQP, and so on, and it enables you to use a custom domain with Application Gateway certificate management capability as well. So that's great. So it's a kind of a single endpoint for all your clients, and supports layer 7 HTTP, HTTPS to layer 4. That's one. The other one that caught my eye is interesting because I love this feature. So API management, the developer portal behind it. I remember when it first got GA'd, and it was a little bit rough, but that was lots and lots of years ago. So they've done an awful lot of work there. The developer portal now has got a whole load of new enhanced features, and the way in which you can customize it and do the layout and everything, it just looks far better. It's a much better experience. So there's new layouts in there. There's new ways of adding widgets and different bits and pieces. You can do different views depending on the audience, and the groups of people that you've got logging in there as well. So you might only want to display certain pages to certain groups that are associated with specific products or APIs. So that's really good, and worth checking out. And that's all in GA now as well. And the documentation's all been updated, obviously, as well.
Awesome. Good updates. I have just one to cover, and that is AKS, Azure Backup for AKS to be precise. So this is the feature where you could now, if you've got clusters in one region and you want to make sure that in case that region ever, goes completely kaput and you need to switch over to another region, you can kind of bring that cluster up again quickly in the other region. And using this feature, what it does, it takes some, as long as you're using paired regions, it will ensure that the backups are going to the paired region, and when you need to, you can just recover the AKS cluster in that second region. And so this is obviously good for disaster recovery. It's also good for, having resilience in case your tenant is compromised, right? So if you have a tenant level compromise, you can ship these things offsite and then, kind of recover them in another tenant if you have to. And finally, if you do have like compliance needs where you need to retain certain data for some period of time, this also serves as a way to kind of meet those compliance needs for your AKS cluster. So that's a new feature. It's in public preview. Regional Disaster Recovery by Azure Backup for AKS. And with that, we can turn the mic over to our special guest, Jose. Jose, thanks so much for joining us today. Please go ahead and introduce yourself to our listeners. Let them know what you do in Microsoft, in Azure, what your passion is there, and we'll take it from there.
Yeah, thanks for having me, Sujit, Russell. My name's Jose Moreno, as you said. I'm working in a division in Microsoft called FastTrack for Azure. What we do is we help customers that are deploying their workloads on Azure to solve the technical challenges that they might have, and to validate that the designs they are looking to implement in Azure are validated and according to best practices. We are a global organization. We are free of charge for customers. So if you're hearing this and you have some workload deployment going on and you would like to get some help from us, feel free to get your partner or your Microsoft account team to nominate, and we would be happy to assist.
That's a good point. Yeah, we should, before the end of the show, we should get those details from you so we can put that in the show notes, how customers can use this feature. But I'm curious, what are you seeing in terms of these deployment challenges? Like what kind of requests do you get specifically, Jose, when it comes to these customers trying to deploy in Azure?
Yeah, great question, Sujit. So one that we are seeing lately quite frequently is resiliency reviews, right? They have a design that they are planning to implement, and they would like us to verify that that design is the most resilient that they can do, or whether they are forgetting anything, especially for customers that have never used Azure. There are a lot of small things to look after, right? For example, around ExpressRoute, there has been quite a surge on the requests that we've got on ExpressRoute in the last few months. And don't forget, I'm focusing on networking, right? So I can answer for networking. For other areas, probably some of my colleagues would be better suited to answer the question.
No, that's a good question. Can you, just for our listeners, can you just give us a quick 2 minute on what is ExpressRoute, just so that everybody is on the same page, and then we can ask some further questions, sir.
Yes, there are different ways for connecting yourself to your applications once you have deployed them in Azure. One is, of course, via the public internet, but for obvious security reasons, not some users or most users do not do that, at least for admin connections. So then the question focuses or pivots towards which ways I have to connect to my Azure footprint using a private network, my private network. There are two ways of doing that. One is over some kind of virtual private network, VPN, with IPsec or software-defined one, or some kind of tunneling technology still going across the public internet, meaning now it's private, but it often doesn't have any guaranteed quality of service. The other is using some private lines, which are on one side owned by Microsoft, right? So you connect to our Microsoft backbone on some of our edge locations or points of presence. And then to connect there, you can work with your network provider, or you can even collocate your own devices in the same points of presence that we collocate ours, so that at that point you have guaranteed bandwidth that you can use for connecting to Azure, be it for transfer data, for connecting to your workloads and do some administrative work, or doing some kind of database synchronization, whatever you need that connectivity for. So it's adding up. It's a kind of private connectivity between your on-premises locations and Azure.
So when you say on-premises, so the customer is currently in their own private data center, right? Let's say they have their own data center for their internal applications, and now they are in a place where they are extending to Azure, right? They want to use Azure, and then this connection you're talking about is between that private data center, which they have their internal applications, connecting into Azure. Is that correct?
Yeah, that's perfectly correct. That's entirely correct. It could be the private data center connecting to Azure, could be Azure connecting back to the private data center, right? Maybe the database is stayed on premises for whatever data sovereignty reasons. It could be as well not necessarily the data center, but some branches, right? Maybe you've moved your SAP systems to Azure, and now the users from all over your organization need to connect to that SAP system to update their CRM systems or whatever system it's running there. So yeah, it could be data center to Azure, or it could be as well branch location to Azure.
Thanks for that. It's quite interesting. I mean, I looked at ExpressRoute like years and years ago. I haven't really kept up to date with where it is and what it does. So I'd be interested to know kind of how big it is now. But when you talked about, or how big it can be, those pipes, when you talked about the requirement being more around security than anything else, I always thought that it was more triggered by the need for low latency connection between hybrid data centers, basically, so between Azure and your on-premise, when you need to do things like replication and stuff like that. Is security on its own, is that a big enough thing to warrant getting an express route, or do you really need to have volumes of data that are passing to and from?
I would say it's security and bandwidth, not necessarily latency, because you can get as well good latency over the internet, with the caveat that it's going to be very variable. All right, you could have good latency but bad jitter, using networking nomenclature. But it's mostly bandwidth. If you want to do big data transfers, like I was mentioning the example of databases staying on-prem or databases replicating from on-prem to Azure, you need consistent bandwidth, and you cannot get guaranteed bandwidth over the internet. You can get guaranteed bandwidth over ExpressRoute.
Okay. And what sort of size do the pipes go up to nowadays? What are the offers that we have?
There are two types of ExpressRoute connections. One type is going over a partner, a network provider, right? So you connect your partner, your network provider of choice, and then they connect to us. Those go up to 10 gig, I think. You can get as well directly a physical port in our edge routers, and those can go up to 100.
Just this morning, I just coincidentally happened to give a customer like an overview on our network watcher service that we have in Azure, right? And in that, one of the use cases for Network Watcher was to kind of monitor this kind of express route connection, right? You could kind of it almost visualizes like the express route for you. And I was kind of amazed how complicated that can be, right? The number of hops that are involved, when you go through from your data center all the way to your maybe your server in Azure. It's got to be a nightmare trying to kind of troubleshoot those kind of things, right? I'm just wondering, like, what is the experience like? I'm sure you've been through a few of these, Jose.
Yeah. So exactly. The thing in my position is that since I'm talking to customers about their challenges day in, day out, I know a lot of about what can go wrong. So sometimes I see the world of a darker color as it should be. Anyhow, yeah, I've been in a good number of situations where the connectivity breaks. It could be because of different reasons, right? Maybe the customer didn't put enough redundancy in the design, and some component there was some single point of failure in the design that broke. So the first step is getting into or identifying what is that component that actually broke. It could even be something that the customer doesn't have visibility on. Like if you think about it, the customer connects to our POPs, and then our POPs connect to our Azure data centers. There's a whole machinery in between that it's opaque to customers, but it's still there. So if something there breaks, usually traffic should be rerouted without any visibility, but sometimes, hey, it's not. So that's where Network Watcher offers some very interesting tools to monitor for this connectivity or loss of connectivity, so that you can take actions, even automated actions, in case something bad happens. One of my favorite ones is Connection Monitor. That's a component of Network Watcher. Network Watcher is the family of tools and panels and charts and visuals that help you understand what's the state of your network. One of those tools is called Connection Monitor. And with Connection Monitor, you can create traffic between two random points across the world. It could be between one Azure virtual machine and one system on premises. It could be between one system on premises and Microsoft 365 endpoints, or between some Azure VM and a random endpoint in the public internet, so that you can monitor that everything is working as it should. So the good thing about this way of monitoring is that you don't really care about what breaks. You care about when things break, right? And then you can react really quickly. ExpressRoute having ExpressRoute monitored not only by Connection Monitor, but additionally with with Connection Monitor, gives you another level of visibility into, hey, is my traffic working as it should? I see a nice dashboard, everything is green, so I'm sure it is. There might be problems around the world, but I know that the network has rerouted around those problems, and I know that my endpoints can reach whatever other endpoints they need to reach to operate correctly.
And when things do go wrong, like Connection Monitor starts raising alerts, let's say it tries so many times and it times out or something. what are some of the tools that you use to help you figure out, okay, where is this problem, right? I know you could look into some logs and I guess in Azure Monitor logs and whatnot, or traffic flow logs. I know there's tools in Network Watcher for flow verification and whatnot. I'm wondering what's in your tool bag, when it comes to things like this.
Yeah. All right. So, first of all, the connection monitor should give you a hint about where the network broke, right? In that long chain of devices you were mentioning earlier, it should give you a hint of up to where traffic went and from where it didn't go any further, as well as the most likely cause of the problem, whether it's a firewall blocking traffic or whether it's some missing routing information, whatever. So depending, of course, of what that likeliest root cause of the problem, then you would go one way or the other, right? If it's a firewall, then you probably want to check your firewall logs and who did the latest change in the firewall rule set. If it's a network security group, as you were saying, right, maybe you want to go to the flow verifier in Network Watcher. One of the tools I find myself using most frequently is the effective routes at the virtual machine level. If anybody listening to this doesn't know this, and you have an infrastructure as a service platform on Azure, that's my number one reading for you tonight. So effective routes give you the list of actually routes that are programmed on any individual virtual machine, or to be accurate, on any individual NIC in Azure. Since in Azure routing is performed at the NIC level, that's fundamental. And you can see things like, are the right routes coming from on-premises? Of course, you need to be able to troubleshoot the on-premises part of the network, right? It's not enough troubleshooting Azure, but if you have lack of connectivity between A and B, you need to be able to troubleshoot both sides. So you might have to go to your local router and verify what routes Azure is giving to you. Typically, since I don't have visibility into customers' local routers, the last point I can look at is the Microsoft POP Edge routers, which is the Express Route Circuit routing tables, routing tables. So those are the two things I look at most frequently: the effective routes at the VM on one side of the spectrum, the Express Route Circuit route tables on the other. So sorry to give you a glimpse of
No, that's
my worst days.
This
that's
is why I don't do networking. It's way too complicated.
So it's clear that if any customer is using an express route, that's obviously super critical for their business, right? I mean, I think that express route pretty much has to be there, otherwise they can't use their infrastructure won't work. How might they, I guess, protect themselves from, let's say, an outage, right? Like a express route circuit going down or something. I mean, I'm sure, like as part of best practice designs for them, what are some of the options they have to make sure that they can continue even in the event there is a circuit failure?
Yeah, another great question, Sujit. So let me try to summarize the components of ExpressRoute, and then we can go into how can you protect each of those, right? The first component of ExpressRoute is the Microsoft Edge routers, or you connect to from on premises. It's always two routers on an ExpressRoute circuit. However, both of those routers are in the same ExpressRoute location, what we call ExpressRoute location. It's very important to distinguish between ExpressRoute location and Azure region. It's not the same. The ExpressRoute location is at the edge of our network, right? And the Azure regions are data centers inside of our backbone. So when you connect to one of ExpressRoute locations, you are actually connecting to a facility owned by Equinix or some data center provider where we co-locate our routers. It's always two routers per circuit, so that's already redundant. Good news. The bad news is that you could consider the express route location as a single point of failure on its own. We recently had some outages. They are unlikely, but they exist, right? Where a whole express route location goes down. For example, if the data center provider has a problem with their cooling equipment, they could have an express route location wide outage. So one of our recommendations is, even if you have two express route routers in every circuit, to consider having a secondary circuit in a close by location. We have even in some cities multiple locations at metro distance. I'm not too familiar with the states geography, but for example, in Europe we have two express route locations in Frankfurt, right? Frankfurt 1, Frankfurt 2. We have two in London. We have two in Amsterdam. So in many big network areas, we have two different locations, and we are working to increase that count. So that's one, right? Connecting to redundant express route locations. The second component is, once you connect to the express route, to the network edge, then from the network edge, you connect to a component in your virtual network, which is called express route gateway. The second strong recommendation that we give is to deploy that express route gateway in an availability zone redundant mode. For example, I was right now looking at a customer like 10 minutes ago. They are following the best practice. They have a number of locations over the world. They are connecting to two express route circuits. In South Africa, it was. In South Africa, we have two different express route locations, all good so far. And then they connect their express route circuits to express route gateways, which are not zone redundant. That could go ugly. I mean, they have a region redundancy, right? So if an express route location if an express route gateway in one of the Azure regions goes, then they would have to fail over to the other. But they could avoid some unnecessary failover if the problem at the express route gateway level is only in one availability zone. If they spread their gateways over multiple availability zones, their design would be much more resilient. So adding up, it's about having resiliency at the express route gateway level by deploying in multiple availability zones, and at the express route circuit level by either having circuits in two different express route locations, or something I didn't mention, by having a backup, for example, with a VPN over the internet in case the primary circuit goes down.
And is this like a hot configuration, like like when you have these multiple circuits? I can imagine that the whole routing situation gets really complicated, right? When you have two circuits, you're never sure now how which circuit is being used for the routing. Like, are both being used? There's only one used. Like, what are the options there?
Yeah, I have good news and bad news there. The bad news is that it's all BGP. The good news is that it's all BGP. So if yeah, if network admins were concerned because they saw their jobs as being in jeopardy because of this public cloud thing, worry not, my friends. BGP runs everywhere, and your skills are still sorely needed everywhere, right? Because to answer your question, yes, as with any other network, you have concepts like routing, equal cost multipathing. You can engineer your traffic to go this way or that way with BGP attributes like AS path prepending. I'm probably throwing out some cryptic expressions for most of the audience. My only goal is here stating that you do need networking expertise to handle ExpressRoute, because guess what? It is a network, right? So you need to know how to manage a network.
When you were talking earlier, and all those different things that are going on and different things that could happen, and how it all hangs together, I was just wondering, and particularly when we talked about the number of logs that you've got to watch through, and when you're doing that diagnosis for security, we've got Security Copilot now, right? That helps you with that. You still need to be a security expert to really ask the right questions and to understand what it's telling you, but it helps you with a lot of that work. Is there plans for a Copilot for networking?
Yeah, we're thinking about how to create an Azure networking copilot and what it might look like, right? Please don't understand this as in 3 months it's going to happen, because it's still early, very early stages. But we are thinking about it, whether it would help customers to troubleshoot problems, or whether it would help customers to select the right product from the Azure networking portfolio, which is another challenge that many customers have, right? When Azure started some years ago, it was easy because we only had VNets essentially. Now you can choose between a myriad of possible design options, right? So that's another area where we're investigating the whether a copilot would be helpful, or as well to flag some of those best practices we were describing earlier, right? A copilot would be helpful as well to answer questions such as, "Hey, is my design following best practices?" And then maybe the copilot would be the one saying, "Hey, your Express Gateway might be better if it were deployed over AZs, over availability zones." So, not answering directly your question, Russell, but we are thinking about different use cases, and troubleshooting is one of them for Copilot, for an eventual Copilot.
Yeah, I mean, it's great to, co-pilots can keep on top of the guidance. That's the thing, right? So you might have deployed something 5, 6 years ago that was best practice at the time, but that's moved on. Unless you keep on top of that stuff, there's nobody's going to tell you unless you've got some kind of tool that's gonna point it out, I suppose.
Exactly, and public cloud is moving so quickly, and so are best practices, right?
Yeah.
Yeah, a lot of customers have been paying attention to this VNet encryption feature that we have now, right? Where previously they would probably use IPsec, and now they're using VNet encryption. Does that play into any of this that you just discussed, or is that like all transparent, enabling VNet encryption? Like, or do they have to think of it from an end-to-end perspective, all the way from on-site to the Azure resource?
I think it should be transparent. We already encrypt traffic going across between our data centers. We use a technology called MACsec, which is a point-to-point encryption between two devices. So you need to do that encryption hop by hop. We do that already, so that when traffic goes from across Azure regions, or from a backbone edge to a region, that's already encrypted. But it wasn't encrypted inside of the data centers until now, right? With VNet encryption, what we do is that when any VM talks to any other VM inside of the same region, that's encrypted as well. That's local to that region. It doesn't necessarily impact the way you enter into the region via express route, VPN, or any other means.
Got it. That makes a lot of sense. Thank you. Wow, this has really been great. Are there any other, like, I don't know, tips or tricks you want to share with our listeners? Or I know we're gonna get the information about the Azure FastTrack for Azure as well from you, but anything else you feel you can share with our listeners before we wrap up here, Jose?
Yeah, if as a listener, there's one thing. If there were only one thing that I would like you to remember after this, would be not to confuse the term Azure region with express route location, which I see a lot of people doing, both Microsoft employees, partners, and customers. So let me go over that again. An Azure region is, say, West Europe, North Europe. The East US 2, US West Central, Australia East. So these are the names for regions. An express location, they are cities. It's Melbourne, Sydney, Chicago. What else do we have? We have Silicon Valley. We have here in Europe, we have Frankfurt, Amsterdam. All right. When you connect to express route, you connect to an express location, to a city, right? And then you connect the city to the region. I see customers saying, "Hey, I have already two regions, so I'm connected to West Europe and North Europe." No, you're not. You're connected to an express route location, so you might be connected to Amsterdam and Dublin. But when you do your diagrams, make sure to separate both, because if you don't, then even in your diagrams, you are not going to be able to identify your single points of failure, right? So the first step for good troubleshooting is having good diagrams and separating these Azure regions from the expressed locations, both in your head and your diagrams, is going to be a huge help in order to come up with a good design. That would be my takeaway for the audience. If I get more people to understand that and remember that, I'm happy.
Yeah, I certainly didn't know that until just now. So thank you for that. That's very useful. This is great. It's always nice to have someone who's has got real world experience in kind of dealing with these kind of problems and also working with customer designs and architecture. So appreciate you sharing those with our listeners today. Russell, any more questions for Jose before we wrap up?
No, just thank you. It's been informative. Yeah, my knowledge on networking was very small before. It's slightly bigger, but still very small. But thank you.
All right, no, thanks for having me, Sujit and Russell. I hope this was useful.
It was. Thank you.